Welcome to my channel. In this video, we'll learn about chemical bonding. So we already know that everything is made up of matter like fridge, house, doors, furniture, everything is made up of matter. So this matter consists of one or more different types of elements or atoms. So when a group of atoms combine, it forms a stable unit that is called molecule. The force of attraction which holds any two atoms or ions together is called a chemical bond. So due to these chemical bonds, atoms combine in different ways. See the example of water molecule. It has two hydrogen atoms and one oxygen atom. The attractive force which holds these three atoms and it forms a bond between them. So that is called chemical bond. So why do atoms combine and why are only certain combinations possible? Why do molecules possess definite shapes? To answer these questions, different theories and concepts have been put forward from time to time. Let's see these theories one by one. Mainly there are four theories, that is Koshal-Lewis approach theory or electronic theory of valence. Second one is valency shell electron pair repulsion theory, VSEPR theory. Third, valency bond theory. Next, molecular orbital theory. So in this video we'll learn Koshal-Lewis theory. So this theory also called as electronic theory of valence. Koshal and Lewis were the first to explain the formation of chemical bond in the year 1916 independently. They explained chemical bonding on the basis of inertness of noble gases. See the postulates of chemical bond. First one is valence shell. Example, see boron atom, atomic number is 5 and electronic configuration is 1s2, 2s2, 2p1. This 2s2, 2p1 is called outermost orbit. So the outermost orbit of an atom is called valency shell. Next, the electrons which are present in valency shell are called valency electrons. Here the boron atom have 3 valency electrons in their valency shell. So only these electrons participate in chemical bonding and the number of valency electrons determines an atom's reactivity and bonding behavior. Next one is octet rule. Any atom tends to achieve a stable electronic configuration like noble gases. So these noble gases have 8 electrons in their valency shell except helium which has 2 electrons. This stability is attained by gaining, losing or sharing of electrons. When atoms gaining, losing or sharing of electrons between them, they forms a bond. So they forms two types of bond, that is ionic bond and covalent bond. See the first one, ionic bond. Bond formed by complete transfer of electrons from one atom to another atom, that is called ionic bond. Koshal noted that electropositive elements like alkali metals tend to lose electrons due to low ionization energy. Ionization energy means losing of electrons from their outer shell, that is called ionization energy. While electronegative elements like non-metals gain electrons due to high electron affinity. Electron affinity means gaining of electron. So see the example, sodium metal, it loses one electron from their outer shell and get a positively charged cation. Example, sodium cation, Na plus ion. While non-metals like chlorine, it has 7 electrons in their outer shell and it gain one electron from sodium to become a negatively charged anion, that is chloride Cl minus. When this sodium and chlorine they transfer electron, it forms a bond between them, that is ionic bond. And next one is covalent bond. Covalent bond means sharing of electrons between two atoms is called covalent bond. So each atom contribute one electrons in the shared pair. If the two atoms share one electron pair, it forms a single bond. If two atoms share two pairs of electrons, it forms double bond. If two atoms share three pairs of electrons, it forms a triple bond. Here see the example, water molecule and carbon tetrachloride. Here in the water molecule H2O, oxygen has 7 electrons in their valency shell. So it gains, oxygen has 6 electrons in their valency shell. So it forms a bond with other two hydrogen atoms and it shares 2 electrons between them. Two pairs of electrons between oxygen and two hydrogen atom, and it forms a water molecule. And Lewis introduced simple notations to represent valency electrons in an atom. These notations are called Lewis symbols. These diagrams illustrate how electrons are shared or transferred in a bond. See the examples of first, second, third, fourth, fifth, sixth, and seventh group elements of Lewis dot structures. When you are writing a Lewis dot structure, place 2 electrons in one side. Don't place more than 2 electrons. Now we'll do some Lewis dot structure problems. First question is, write the Lewis dot structure of CO molecule, that is carbon monoxide. Here we must follow certain steps to write a Lewis dot structure of any molecule. So first step is count the total number of valency electrons of carbon and oxygen atom. So carbon atomic number is 6 and electronic configuration is 1s2, 2s2, 2p2. Here this 2s2, 2p2 is called outer orbit and there are 4 electrons are present. These are valency electrons. Next, oxygen atomic number is 8, electronic configuration is 1s2, 2s2, 2p4. This 2s2, 2p4 is called outer orbit and there are 6 electrons are present. So total number of valency electrons means 4 plus 6 is equal to total 10 valency electrons present in this molecule. Step 2 is identify the central atom. Generally, the least electronegative atom occupies the central position. Here, carbon is the least electronegative atom. So, this is the central atom. Step 3 is write the skeletal structure of CO molecule, that is C and O. Last step is draw a single bond between carbon and oxygen and complete the octet rule around oxygen and carbon. If you draw a single bond between carbon and oxygen means one pair of electrons are shared between carbon and oxygen and remaining electrons are placed around the carbon and oxygen. Here carbon has 4 valency electron. One electron is participate in the bond formation and remaining 3 electrons are lone pair, and also oxygen has 6 electrons, so 1 electron is participate, so 5 lone electrons are there. If you form a bond between single bond between oxygen follows the octet rule but carbon doesn't follow octet rule, so form a double or triple bonds between carbon and oxygen and see the both atoms must follow octet rule. Then if you form a triple bond, both carbon and oxygen follow the octet rule and remaining electrons are lone pair electrons are placed around the carbon and oxygen atom. So like this we have to write a Lewis dot structure of carbon monoxide. So before solve this problem, here I am giving simple trick to remember valency electrons of any atom. See the periodic table and count the groups from left hand side to right hand side. Leave that D black elements. So S black to P black element 1, 2, 3, 4, 5, 6, 7, 8. If you take second group, so this 2 tells us all the elements in this second group have 2 valency electrons in their valency shell. Like that, if you take any group, the number tells us that valency electrons in their valency shell. So see the question, write Lewis dot structure of ammonia, that is NH3. First step is count total valency electrons. Ammonia, in which group it is? It is fifth group. So how many valency electrons are present? 5 valency electrons. And how many number of hydrogens are there? 3. So 5 plus 3 means 8. Next, identify the central atom. If you don't know least electronegative atom, just remember that which atom is single in the molecule, that is the central atom. So ammonia is the central atom, and draw skeletal structure of this molecule. Next, draw a single bond between nitrogen and hydrogen. Here total 3 hydrogen atoms are bonded with ammonia. So draw a 3 bonds between among the nitrogen and hydrogen. Now the remaining electrons that is present in the nitrogen, so place above the nitrogen atom. So single electron pair is present on the nitrogen atom. So always remember hydrogen forms only single bond. So here bond pairs are 3 and lone pair electrons are 1. So like this you can easily write Lewis dot structures and easily identify the valency electrons. So to know formal charge in an atom, we have a formula, that is number of valency electrons in the free atom and minus number of unshared electrons on the atom minus number of bonds around the atom. So first see the example, that is ozone molecule. Draw the structure of ozone molecule and give numbering from each of the oxygen atom from central atom to remaining 2 atom, that is 1, 2, 3. And take first the central atom and see the formula. Based on this formula, first one is number of valency electrons of the free atom. Oxygen have 6 valency electrons minus number of unshared electrons on the atom. So 2 electrons are there minus number of bonds around the atom, that is 6 minus 2 minus 3 equals plus 1. Take second oxygen atom. So second oxygen atom valency electrons are 6 and number of lone electrons, that is 4 minus number of bonds 2 equals 0. Next third atom, that is the other end is third atom. Number of valency electrons 6 minus number of lone pairs 6 minus number of bonds only 1 is equal to minus 1 charge. So like this we can easily identify the charge, formal charge of any atom in a molecule, and see some example of these formal charges. See the limitations of Lewis dot structure and octet rule. This theory is useful for understanding the structure of most of the organic compounds, and it applies mainly to elements in the second period of the periodic table. So there are 3 types of exceptions to the octet rule. That is, first is the incomplete octet of the central atom. In some compounds, the number of electrons surrounding the central atom is less than 8. So this is especially the elements having less than 4 valency electrons. Example, that is lithium chloride, beryllium hydride and boron trichloride. These 3 molecules, the central atom lithium has only 1 valency electron, beryllium has 2 valency electrons and boron has 3 valency electrons. So it does not follow the octet rule. Next, odd electron molecules. In some molecules with an odd number of electrons like nitric oxide and nitrogen dioxide, the octet rule is not satisfied for all the atoms, because nitrogen has 5 electrons in their valency shell. So these nitric oxide and nitrogen dioxide shows resonance structures. And next, third, expanded octet. This octet rule is applicable only up to second period elements. Beyond the third period of elements like n or n minus 1 into d elements, there are more than 8 valency electrons around the central atom. Example, sulfur dioxide, sulfur trioxide and some of the coordination compounds, they shows more than 8 electrons in their valence shell. So this is called expanded octet rule. And this Lewis dot structure mainly depended on the inertness of noble gases. Inertness means the noble elements, they have 8 electrons in their valence shell, so they are not ready to participate in chemical reaction. But some of the noble gases like xenon and krypton, they combine with oxygen and fluorine to form different type of compounds like xenon fluoride and krypton fluoride. And this theory does not explain the shape of the molecules and the relative stability and energy of the molecule. So these are the limitations of Lewis dot structure, and try to do this worksheet. Write the group number and the number of valency electrons for the given elements and draw Lewis dot structures. So do this worksheet, and if you have any doubts, please write in the comment section. Like, subscribe and hit the bell icon, then you will get the regular updates of my channel. Thanks for watching. Try to do this work.